All right, so this one's not one where you can just plug in an equation and get an answer, which always makes it a little bit more difficult for me, I think. But you had to come back, and I said this at one point in the notes, and it wasn't a huge emphasis, and there's a potential that there will be a question on the test like this. Probably not more than that, but where you have to know what the area, right? This is the area of this shape, the shaded area, right? We have to know what that represents if this is velocity and this is time. So one of the keys is when you're finding that area, what you're going to be doing is multiplying velocity times time. And that's going to be the area of this graph, right? Is a velocity times a time. And then, you want to go through and figure out which one of these does that match up with. And it turns out it's actually going to match up with displacement, because where does this come from? It comes from that v equals d over t, right? And then frequently we rewrite this as a triangle equation where we have v here, t up top, and t there. And then we can see that d is v times t, right? It's not momentum. We haven't talked about momentum yet. It's not acceleration, because acceleration is the change in velocity. You can see the acceleration of this graph on this graph, but acceleration is change in velocity divided by time, right? So you're going to see that as the slope of this graph here. And it's not speed, because speed is just velocity without a direction. So that kind of leaves us with displacement. So, that could have helped you if you just, we did a process of elimination, right? It shouldn't be the thing that we haven't talked about. Acceleration would be the slope of this graph, not the area of this graph. And speed, that's just velocity without direction. It's the kind of scalar version of velocity. And also, right, this is something worth just trying to memorize as best we can, that the displacement we can find on a velocity time graph by taking the area.